A very good morning to all the participants. I welcome you all to day 2 of session 3 by topic name Tunneling as Transportation, a case study by KL Mohan Rao sir. I welcome KL Mohan Rao sir for this session. Welcome, sir. Now I request Dr. Asif Iqbal Momin sir to introduce today's speaker, KL Mohan Rao sir. Sir, over to you.
Good morning, sir.
Sir, unmute yourself.
You can hear me now?
Yes, sir. I can hear you.
Yes, sir.
Good morning, sir.
So good morning to all the people who have logged in.
Sir, just a minute. I'll just introduce you and then we'll start.
Yeah. Okay. Okay.
Thank you. I'm honored to introduce today's resource person, KL Mohan Rao. KL Mohan Rao, he joined Builders Association of India in 1980. Vice chairman and chairman in the year 2002 to 2004. Later, he became state chairman in 2005. Since then, he has been involved in training activities, Builders Association of India, till date. And diploma in HR from Bangalore University. He is not associated with teaching, but associated with training and placement. He is entrepreneur, 35 years, having his own small-scale industry, specialized in computer rooms, sound, thermal insulation, false ceiling, etc. He has worked with ISRO Hassan, worked in the field of training. He is in the training since 2002. He was a chairman of Builders. He is a chairman of Builders Association of India. Established the first training center for Builders Association in India in the year 2003. Since then, he has conducted 23 numbers of training programs for final year civil engineering, mechanical engineering students of VTU, Visvesvaraya Technological University, Belgavi. And he has motivated and helping them to become a self-employed or to get employed in civil construction activities. Sir has successfully trained and employed more than 5,000 civil had been, and I have been sending you the students for training and placement. I think you remember the students which we have sent it. You remember with the name also. The students have already well settled now. They have been trained and placed with your help, and they are now well settled in abroad even. I think you even remember with the name also. With
Yes.
this age, I am hats off to you, sir. You with your all tremendous work on training and placement. Most of the students were not at all placed in the earlier in 2000, where the demand for the civil engineers was less. But still, then you strived hard and you had made an unity of all the builders throughout the Karnataka in the Bangalore region. And you started with the training center, and you have placed both civil as well as mechanical engineering students in different industries, where now the university has started with what you call internships now. But this internships was already done by you in the Builders Association of India. And most of the colleges, almost all in the Karnataka, have sent the students for the training, and which with there they have been placed. And my my host colleague, Naeem Inamdar, who is also a student who has been placed in Builders Association of India, you could remember, but later on he left and he had joined to the teaching. Thank you, sir. Sir has been involved in most of the training activities. He was conferred with Bharat Ratna Shri M. Visvesvaraya Award on 24th December 2020, and for his dedicating and continued service in the field of training of artisans, supervisors, and engineers. Even not only the students, sir has involved in training to masons, every individual members who have been associated with the construction industry, all those has been trained under the sir head. Sir is presently the chairman of Instruct, and he is the president of CIDA, that is Construction Industry Development Academy. With this, I welcome you, sir, for this session on the tunnel for transportation, a case study. Over to you, sir. Thank you for accepting our invitation and being a resource person for this session. Thank you. Over to you, sir.
Thank you. Thank you very much. Very kind words. Yes, I have been associated with BLD from 2002 onwards. I've been visiting your premises. I wish I was there instead of sitting across here. I love the place and the hospitality you people extend. Thank you very much. Today, we are going to talk about tunneling as transportation.
Sir, you just open your PPT.
Sure.
No, at the bottom, you have the presentation now. You just open that.
Don't click to this, sir. You open the PPT. That's it. Open the PPT. Okay.
Yeah.
Make a slideshow.
Slideshow.
Okay, sir.
So today, as we are saying tunnel as a transportation, you will be aware that the whole world is now taking tunneling as an alternate source of transportation, of let it be the human or let it be the we are talking about transporting oil from Dubai and then sending water from India to Dubai. That is the quantum of tunneling which is being used under sea. So this is how the whole world is adopting to this place, because it will not be interrupted in between once the tunneling is done. So the whole system we are going to talk about: why tunneling, how tunneling, what is the how tunneling is done, advantages and disadvantages, and also a case study of the Bangalore Metro Rail Corporation, which did its underground tunneling in the heaviest density of Bangalore, the old city of Bangalore, where all old structures are there. It shakes on its own, but we did the drilling about 60 feet below the city market and Chickpet area, and we faced a lot of challenges. So this is how we will be covering this area. So what is tunnel? Tunnel is an underground passage used for transportation. Though could be used for carrying freights and passengers, water, sewage, etc. Tunnels are more economical than the open cut beyond certain depths. Open cut means we are opening it up. Calcutta Metro did the open cut system, and it had terrible problems because in a very high density area they had to cut it open, and there were so many other problems like sewage, telephone line and water line, everything to be corrected. It took them real 10 years or 10 years and above. So tunnels avoids disturbing and interfering with the surface life and the traffic during constructions. They permit the transmission of passengers, freight, and it may be a transportation of utilities like water, sewage, and gas. The operation and the constructions are carried out underground without disturbing the ground surface. That is why it is called as tunneling. Tunnels are underground construction used for transportation. The feature, advantage, disadvantage, and methods of tunneling has been discussed in this presentation. The tunnel engineering is one of the most interesting disciplines in engineering. The work is complex but difficult throughout its course, even though it is interesting. Tunnel is defined as an underground passage that can be used for transportation purpose. The discipline will let us know the knowledge on the structure. Yeah, this discipline will let us know that knowledge of structural and concrete engineering is not enough. and thorough knowledge of geology, mechanical engineering, geomechanics, and new construction technologies is also essential. So those people who are thinking civil engineering is only concreting, no, you have to have the additional knowledge about the other systems also. The two main factors that help in the efficient route of tunnel is the alignment restraints and the environment consideration. The underground, as we know, it is heterogeneous in nature. A proper inspection of the nature of soil, rock, and water table level, and all alignments restraints have to be made before fixing the route. So they have to make a real survey of it and see. Most of the time, the survey is done along the big roads of the place. The site is chosen for tunneling is such a way that no inconvenience and difficulty is caused to the environment in the area, including those people who are living in that area. Tunnel in loose rock and soft soil is liable to disintegrate, and therefore a lining is provided to strengthen their sides and the roof so that it prevents collapsing. So as the tunneling goes on, the machine, the TBM, that is the tunnel boring machine, will go on laying the lining to it. That means as soon as it digs about 3 meters, immediately from behind, we are bringing in the already made segments, and it is brought inside and it is placed so that there is no collapse or water leakage inside the tunnel. The tunnel method chosen depends on the ground condition, the water level, the tunnel drive length and the diameter, the tunnel depth, final utility requirement, the shape of the tunnel, and the risk of construction. Surface and air interference is restricted for tunnels. Provision for tunnel is easy gradient, helps in reducing the cost of hauling. So if you are doing open cut, you will be cutting and you will be creating a lot of muck, and it has to be taken out. It has to be taken and dumped somewhere else. For the transportation of public utilities, tunnel methods have a remarkable advantage compared to the bridge. The dangerous open cut to the nearby structure when it is needed is solved by tunneling systems. When we are cutting it with the, you must have seen on the roads, this other methods are being used. We are removing the muck, and then when we are removing, sometimes the neighboring structures will also get damaged, and lot of precautions for that has to be taken. Tunnels grant greater protection in aerial warfare and bombing conditions. You remember Iraq war when these people were just going inside the tunnels and being there. Even if the Americans were bombarding them, everything was up there because these people were nearly 60 to 100 feet below the ground and they were well protected. The tunneling method gains a certain disadvantage, which is due to the complexity and difficulty. Some of them are the initial investment cost for commencing the tunnel is high compared to the open cut method. Initial investment because we have to go down, and the machinery which has to be brought in. In Bangalore Metro, we had imported machines from Japan. We had brought it from Korea. We had brought it from China. High skilled and experienced designers and engineering team only will work best in these operations. In Bangalore, those people who were operating the TBM, they were not allowing our engineers into the cabin where these systems were going on, because they felt that Indians can learn it very fast and we may replace them. So it is a very difficult situation when we have to coordinate with this Chinese, especially Chinese. They were very difficult. So they were never allowed us to go inside to see what is happening, and they are very well experienced. And today this is an opportunity for all the young engineers who are coming out in the future to think as tunneling as their alternative system, and it is a highly paid job. So if you can start concentrating and how to go there, how to get into that field, I think it is better now. Those who are in the third and fourth year, please concentrate on this line as an alternative source. Higher and constant supervision from the start to the end of the tunneling project is necessary without any compromise. There cannot be any other way than the project rules which have been set. High sophisticated and specialized equipments are necessary to perform the tunneling process. There is always a debate arising on the cost that is consumed between the open cut tunneling techniques. To conclude, it is more economical. That means it is the tunneling is more economical than the open cut. Considering the following factors, open cu- uh, o- open cuts are found very costly at deep cutting of soil. That means if you are going beyond 20 meters from the ground, it becomes a very costly thing. With the varying nature and slopes, this method will account for large volume of excavation. Whatever is removed, it has to be taken out, it has to be transported, a place has to be found, it has to be kept there, unless you have already identified a place where it can be dumped and it can be, for filling of soils, but so much volume cannot be filled. At this situation, tunneling methods will bring more economy than the open cuts. When the materials of drilling is rock, open cut performs well and less amount of excavation and finds it cheaper. So if you are having a very big rock there and you are cutting it off, it is open cut method is cheaper, while tunneling method is found difficult to show its activity. So, what is a tunnel? We have got a tunnel lining. So, and then we have got mass property, the strength, stiffness, groundwater, passage structure, and ecology. Interface is or the original geocentric stress, which is due to the excavation. Then construction technology, we have got phase sequencing, phase size, length of the partial excavation, and speed of excavation. So what we have done in Bangalore Metro, I'm just giving you a case study, carrying out civil works related to the development of infrastructure towards public transport system is a challenging task in the present day of urbanization condition. Such work in city of Bangalore, where there is an acute shortage of space, and geology controls the process of construction of metro rail corridor. BMRC had taken responsibility of implementing Bangalore Metro Rail project and faced several difficulties in implementing the first phase of the project. Bangalore, as you know, is a plateau, and it is not having a continuous, the strata is not a continuous one. And we faced a lot of problems. One such challenge was construction of tunnel and underground station. So underground station, we have to really go deep, nearly about 60 feet or 80 feet. Tunneling is mixed strata below the major roads, and old building influenced the process. So we have got in the place where we had to go underground was Chickpet area and the market area, where old constructions are there. Many old structures are there. People are residing there for more than 150 years. Maybe the buildings are also as old as that. And the other thing was there was no planning at all. One fellow built next to the one, I think other buildings are supporting these buildings. Because of the support from all the three sides, these buildings have survived all these things. So, one such challenge of construction of tunnels and underground stations. Tunnel is a mixed strata below the major roads and the old building influenced under the process. When we were tunneling in Chickpet and the market area, we had many times we had to evacuate people from the place because sensors were put in all this old buildings to see when the rotation of the TBM was done. Sensor, if it was showing danger, they were supposed to be evacuated, and they were put in lodges, paid them for the whole time, and then we had to redo the structures, strengthening of structures before we allowed them to come inside. So that is an additional cost, and also the additional time requirement is involved. Tunneling in ground filled with huge boulders and excavating very hard rock by controlled blasting of station evacuation where such difficulties come. So we were doing this open evacuation. We was done near Central College, because the place was filled with very hard rocks, and we had to open it up, and the blasting was carried out, and controlled blasting. We had to use lot of techniques for that. And then at a particular time between maybe 11 to 2, the blasting used to go on, and the traffic was restricted from both the sides of Central College, from the Kempegoda Road and the college side. And lot of precautions were taken, just like a mining operation. It used to be giving a siren, then the people were made sure that the people vacate the place, and the blasting used to happen many a times. In spite of all the safety precautions, this rock is to come and fall into the Central College. So this is what is a challenge when we are blasting for excavation. Let us understand the challenge faced and the situation found in the tunneling and station excavation. In the modern India, number of tunnels were constructed in 750 kilometers long Konkan railways, which was constructed between 1990 to 1998. Konkan Railways has 93 tunnels. All of them were constructed by conventional methods except one tunnel in Honavara, Uttar Karnataka district, Karnataka state, which was constructed by using an open shield. That means it was open, it was ripped open, and things were done there. Future. Now, the future railways, tunneling is piping. It's a new thing which is happening. Dubai to Mumbai underwater tunnel train, a distance of 2,000 kilometers to cover a distance in 3 to 4 hours for oil and water transportation. It's a news. So you have to see that you have got lots of opportunity, because the whole world is now talking about tunnels under the sea. Mumbai to Ahmedabad, it is a 508 kilometers underwater tunnel for 21 kilometers is planned, and the planned train financial assistance is coming from Japan, and the work is under progress. And you will get the Kolkata underwater train for a distance of 17 kilometers at a depth of 30 meters. 508 meters length tunnel will be completed shortly between the Hooghly River and the Salt Lake to Havra. So this will run at a speed of 80 kilometers per hour. So that will be the first underwater train in Kolkata you will get. So you don't have to visit foreign countries to see what is the marine life, and you can see the whole system there. Open shield refers to the type of tunnel boring machines, TBM it is called, and with which the cutting face of the shield is open, allowing direct access to the soil surface. So tunnel boring machines are put in an open shield. It is cut for nearly about 100 meters. It is cut, and then this machine is put inside there, and the tunnel boring machine is used for open shield methods. Open shield are used to provide lateral support and can also accommodate manual excavation as opposed by other system types of TBM to provide frontal support. So TBM is lowered into a place where this tunneling has to be done, and then it is supported from all round, and also it has to be pushed with the frontal support. So this is the TBM, the tunnel boring machine. You can see it is 300 meters. It's a complete factory inside the town tunnel. 300 meters and so many people working at different stages. The first thing here you can see is a cutter. Inside, this is a place where all the engineers are sitting, and then this is a place where everything is being, the surface which is ground taken off, all the excavation is taken off and then pushed outside the tunnel, which is far away. So this is the TBM, 300 meters long and maybe about 30 meters in diameter. So tunnel boring machine are extensively used first time in India by Delhi Metro Phase 1, subsequently Bangalore Metro and many other metros, as well as in other works related irrigation, hydropower, disposal, sanitary and drinking water. Tunneling is being used extensively now. Tunneling is used, tunnel boring machines is very safe tunneling method, which has brought drastic improvement in tunneling works. So tunnel boring machine is safe. Earlier, machines were of open type wherein shields is used only to support the soil collapse. So as soon as you start opening up a tunnel, you have to start giving a packing so that the soil does not collapse and it does not give hazard to the people working. So this is how it is. You can see this is the tunnel entrance, and you can see this whole system. This is the place where the shield has been provided with. Those days it was bricks and timber. You can see all these people. This is the tunnel. They are coming down by a shaft, and then this is being worked, and you can see a manual way of removing all the muck from there, brought here, and then it is transported through the shaft and taken out. So this was the version where it was happening before. A tunneling shield is a protective structure used during the excavation of large man-made tunnels. So you have seen the figure. We have shown you what it is. When excavating through ground that is soft, liquid, or otherwise unstable, there is a potential health and safety hazard for the workers and the project itself. Uh, uh, from falling materials and caving in. So I have explained to you why this shaft is lined up. Excavation in this type takes place with the help of conventional machine like excavators. So excavators will be used and the material will be removed. Pressure on the face of the tunnel cannot be increased in open type of machine. Open type of machine if you are using, and then if you increase the pressure of the excavator, there is a chance of your damaging the place, damaging the structures which is along the tunnel. In rocky strata which does not need lining as support, if it is a complete rocky mountain, if we are going to open up, then we do not need any support. You can remember that in Jammu we had opened a tunnel about, I think, I'm not very sure, about 8 to 10 kilometers, which was opened by the road tunneling people, and it is connecting Jammu directly to Leh Ladakh, and it has saved a lot of time. It was completely done under the hillock, and it is completely rock only. So not many places we do not need any shield at all. So that is how the no support was required there. But drilling was a big challenge, and type open type machine called as cutter head is used, such machines will not have a shield. So this is how the TBM is. You see ahead, this is the TBM face. These are lot of cutters are there here, and then TBM shield is 6 meters. So here, this shield is about 6 meters long. That means nearly 20 feet. And then there is a place where the L1 zone. So all the muck which is collected, it is getting collected here, and then from this it comes here, and then it gets transported through I think there is a conveyor belt. It gets transported outside, and also the lining for the surface is already readily kept ready there, and it gets fixed up automatically. And there is a very big slide I'll be showing where the whole operation is explained. Earth pressure balancing machine. Earth pressure balance is a mechanized tunneling method in which the excavated material is used to support tunnel face west. It is being plasticized using foam, slurry, and other additives to make the transportable and impermeable. So when this material being used, and sometimes this material we use for plasticizing, so we are going to use some more additives, and then it gets it can be used for the lining also. Slurry machine. Thin slurry is thin, slopy, wet mixture of liquid and solid components. Sludge and slurry is the byproduct of industrial refining and wastewater treatment process depending on the industry. It contains non-hazardous water, mud, oil, and biosolid and other debris. So this slurry, what is removed, it is taken to the tunnel, the place where the tunnel starts, and the material is recycled. The rock debris from the tunneling is usable for other usable thing. The most common concrete aggregates or the base for the road. So in Bangalore near Sangam, we had a recycling system there. Crushers were there where all the material, the rocky material which came out by the conveyors, were brought to the crushers there. It was sorted out, it was crushed, it was used for concreting. Then big rocks were used for laying of roads. So the trucks used to be waiting that, and then it was taken away. So no material was wasted. So a lot of planning was done so that the material is not dumped at any place and making another mountain. It was shifted off, and it was used for concrete as concrete aggregate, and also road filling, road building. Crushers and screeners normally used in quarries are stationed at the tunnel site for the purpose, and which is to crush and screen the rock debris for further use. Excavated material is transported from the tunnel face to outside the shaft as waste slurry. Before knowing about these machines, it is essential to know the working of the closed type of tunnel boring machine. A closed type tunnel boring machine consists of horizontal thick steel cylinder which is known as shield. I had shown you illustration. There is a shield. The shield protects the machinery and technicians against the earth above. The cutter head, where the cutting tools are placed, will be it will be at one end of the shield towards the tunnel face. So you had seen the cutters there. The cutter head is there. Lot of cutters are put there, and it goes where it faces the tunnel face. Cutter head is a heavy set part of TBM. Cutting disc and the scrapers are placed in the cutter head. So you have got the cutting tool, and also there is a scraper. If there is a loose soil or any other loose soil is there, the scraper will go on scraping it. At the same time, the cutting tool will go on drilling and removing all the rocks there. Design of cutter head is mainly based on types of earth to be excavated by the machine. So when we are doing the soil investigation, we know what type of soil is we will be encountering, and based on that, the design of the cutter head is done. A machine to work in soil will not have cutters disc, it will have only scrapers. So if it is a loose soil, it is only soil there. In Bangalore, the plateau, we had lots of mixture. In one strata, when we are digging, we have got the sand salt, sand silt is there. We have got a mixture of sand and rock. Then we had hard rock. So like this, it was not predicted. So the maximum drilling what we could do, we had done is about 60 to 80 feet in the Majestic area, and we found the soil completely different from one meter to the second meter. So everything is a mix. Especially in Bangalore, it was a very big challenge. So we have to use both the cutter disc and also scrapers. So here you are. See, there are scraper, there is cutting tool here. These are all the scrapers which will just go on scraping. And this is the cutter head, which can be seen from inside. This is behind, this is the machine, and that is called the shield. And in front of it is this cutter shield. So lots of challenges will come in the tunnel boring machine, which will be illustrated now. So a machine to work in the rocky strata uh, will have cutter disc mounted on the cutter head. There will be they there will be a suitable number of drive motors for rotating the cutter head. The cutter head will be rotating by the use of motors because it requires lots of pressure. So there will be a segment erector which is used to place the tunneling lining. Segments are, in Bangalore Metro, we had about 6 segments with a small T there. So 6 segments are placed inside the machine, and as soon as it starts drilling, the segments are pushed inside, and then it is erected with the machine help, and then whatever is the gap between the segment or the shield, I don't know whether you are imagining. So you are putting a pipe inside, a big pipe going inside, but the pipe is made into 6 different segments, and then it is assembled by the TBM itself, and it has got a T joint, so which will, just like a dowel, it goes and sits there and tightly packs it into the diameter of the shaft or the tunnel, and the difference, whatever is the gap between that, is filled with slurry with this machine itself, so that it becomes pakka and no water seepage or any material will come out from the shield. Tunnel lining can be a concrete or steel, concrete being widely used. So we have to do all this concrete tunnel lining will be done somewhere else. It is precast, brought to the site, assembled inside the tunnel boring machine, and then it is fixed there. And as regard to removal of excavated muck, there is a difference, major difference between slurry type of TBM, earth pressure balancing type of TBM, which will be explained below. So as I told you, concrete precast material is used. In Pina, we had a very big casting yard. Now, when we are doing a lot of work along the Mysore road and the other periphery road which is connecting this South Bangalore to Bayapanahalli. So we are making a complete circle, and lots of concrete blocks are being made at different sites. So slurry type of boring machine is machine. Excavation takes place in presence of a liquid. A liquid is poured and pumped inside the tunnel, and the tunnel mud with which will have a specific gravity of 1.12 or 1.2. So when the liquid is actually pushed inside that, the liquid can be made by using bentonite clay or using polymers. The tunnel mud is pumped through the pipe to the excavation chamber. So this whatever is we are putting a lot of pressure, and this bentonite clay or the polymer is being pumped in front of the cutter, and that whatever muck is collected while drilling, that is taken away by the by conveyor belts. It is taken outside and it is filtered, again recycled inside the tunneling. Excavation of TBM happens due to rotation of cutter's head and forward movement of shield and help the truss jacks. So the rotation is happening by the cutters, and behind there is a truss. There is a very big thrust is given by the truss jacks, and the pressure is created, and that is how the cutting goes on. The tunnel mud and slurry is kept under great pressure to create a continuous support to the face of excavation. So this mud or the slurry, the bentonite and other things, is kept under a big pressure in front of the cutter, so that all the muck which is being removed gets collected at the bottom and it goes back. So pressure is very important there. The excavated stuff also with the slurry is taken out to the slurry plant in another pipe. During working of TBM, the slurry is continuously circulated between the slurry plant and excavation chamber. The slurry plant, the excavated stuff, is separated from the slurry in the gravel separator, sand separator, and silt separator. As I told you before, it goes by the conveyor and it goes to the place where the slurry plant is there. It gets separated and it is reused somewhere else, and the slurry comes back. It is recirculated. The slurry plant is shown here. As you see here, tunnel surface section. So there is a pressure from this side, that is the front of the cutter, the soil pressure. And here you can see this one pressure here, and another pressure is coming from there. And from inside the cutting chamber, we are putting pressure here, and this is another pressure. So all these cutters and all the slurry gets collected below there, and you can see this pipe. It is going off outside through the conveyor belt. It gets separated later on. So slurry shield components, cutter head. This is the cutter head. Excavation chamber is this one. This is the excavation chamber. Then air bubbles are there here, so that the air bubbles will continuously pump in air there, so that it's also starts separating there. And then working chamber is this one, and slurry shield line. See, you can see this slurry shield line is this one. So the slurry shield line is this one. It just goes from here. Slurry return line is in green. So from there, whatever is coming, it comes back from there. Pressure, the pour water pressure, lateral effective stress, cutting head pressure, slurry face pressure, slurry radial shield pressure. There is a shield which is coming here. So there is a pressure from there, and the shield goes further, and it gets assembled here, erected here. Then grout NS pressure, NUS pressure. So we have to create lot of pressure for all the activities here, and it is constantly under a controlled pressure. In an earth pressure balancing machine, the excavation chamber is always kept filled and with excavated stuff, and excess excavated material is taken out with the screw conveyor. The conveyor chamber is kept under suitable pneumatic pressure to avoid water entry into the chambers. Foam is injected through some nozzles in the cutter head to keep the excavated stuff cohesive so that it moves smoothly on the smooth cutter. So whatever excavation is being done, whatever cutting thing is being done, it'll be given, a foam will be given so that it is uniformly, and it'll be stuck together, and when the conveyor screw moves, it moves behind. So this is the conveyor screw. So cutter head and excavation chamber of the slurry type of TBM. So I have already shown you this L section, except from the above, removing excavated stuff through the slurry or screw conveyor, other arrangements in both the type of TBM will almost match each other. So this is the cutter head, this is the bulkhead, these are the shields, what I told you. This is the trussed cylinder. This is the truss cylinder which is pushing the shields and putting them in place. So installed segment. This is already installed. You see, as I told you, the segments are already brought in 6 different pieces, and they have been installed here. So as the drilling goes on, installation goes on from behind. So excavation chamber is this, screw conveyor is this one, gripper shoes. So all the shoes what we were talking about, the gripper shoes is here. Then the belt conveyor which takes the muck behind. Two types of forces are applied in TBM for excavation. One is to rotate the cutter head, that is the torque, and the other is to push the shield, that is the thrust. Combination of these two forces are used for excavation in rock and soil. Face is kept under pressure. That means beyond the cutter, it has to be kept under pressure to keep the water away from entering the machine. So if there is a pressure in front of the cutter, this water will not flow inside the machine, the chamber where the operations are doing. If there is a loss of water from the area near the tunnel alignment, water table in the vicinity will be affected, which will cause settlement. So we have to be very careful to see whether there is any tanks or any reservoirs in where the tunnel is going, and uh, if there is any leakage, the whole tunnel will be, we can have water coming inside the tunnel. And I don't know if you people know, there was a Koina dam near Pune. Something like this has happened. It started leaking from somewhere, and suddenly the whole water was leaked out, and there was a very big accident those days, maybe in the 70s, that had happened because of the water table leaking. So it should not, we have to be very careful to see that the water table and the pressure inside the tunnel is kept in such a way that the water cannot seep inside before the lining is set in. If there is a loss of water from the area near the tunnel alignment, water table in the vicinity will be affected, which will cause settlement at the surface. As soon as the water comes out, there will be a caving system. Caving in will start happening, and all the buildings around will have effect on that. The settlement will affect stability of the building, road, and any other surface structures existing in the surface. So this is what we have to make sure, that the pressure inside the tunnel and outside tunnel is balanced. Therefore, keeping a face under suitable pressure is very essential. While excavating the rock, revolution of the cutter head is kept higher. So if there is a rock there, the rotation of the cutter will be with the 4.5 revolution per minute, and thrust force is kept low. So you don't have to. We cannot push the by thrust. We cannot. So because there will be rock there. If there is a rock, we have to go very slowly. In Bangalore, this 4.5 did not. I think we were only using 2.5 to 3 revolutions per minute because of the buildings above us. In case of excavating soil, revolution of the cutter head will be kept low and thrust will be kept high. So uh, the soil, if it is only soil, no, the cutter will be having a higher speed, but the thrust, I'm sorry, the cutter head will be kept low and the thrust is more. In case of a mixed startup, both the above guidance cannot be met. So we'll have to judge and see whether there is rock is there, soil is there. Based on the experience of this person, the speed is adjusted. When the face is partially rock and partially soil, this guidance gets violated in respect with respect to the rock or soil. It is difficult to cut the rock with a lower revolution, and at the same time, soil gets excavated quickly, and the face needs to stand on its own for a longer period, which may cause a collapse of the face. So, too much of we have to cut a lot of rock, the and also there is a soil. It has to be excavated quickly. It has excavation should happen very quickly, otherwise it will get settled in the front, and then cutting will become very very difficult, and there will be a damage of the cutting tool, which is likely which more likely while negotiating the mixed strata. So you can see this damage of the cutters. So this is a new cutter, and these are the damaged cutter, because there is a mix of soil and rock together, and we cannot see what is happening in the front. And this replacement takes place, and once this cutter has to be replaced, it takes about 2 to 3 days for it to be removed and reassembled. Careful movement of the machine, close observation of various parameters like face pressure, advance rate, theoretical and actual excavation quantity, etc., is very essential while mixed phase is encountered. So, removing of only soil is not so difficult. Removing of a rock is not very difficult, but when there is a mix, then a lots of tool damage and interventions will take place. And in Bangalore, it used to happen many times, and sometimes 3 days 4 days were lost just to remove the cutters, remove, replace, and again do the job. In case of a boulder having more diameter size of the TBM has to be negotiated, the challenge faced by the tunneling team goes tough. So we may have very huge rock diameters, which we would have not come across when the soil investigation. Sometimes it gets hidden also, and if we have to negotiate the big diameter the rock, it becomes a very tough challenge. Water moving along the surface of the boulder during increase or decrease of the surrounding. So water, as I told you, very big boulder being tapped, so water table from the top may also come inside into the tunneling. Fine particles along the surface of the boulders are subjected to the moving water repeatedly and gets washed away. So there is a lot of fine particles which will be settling on the surface of the cutting machine. So we have to wash it off with water. Mainly coarse-grained particle remains in the area, causing loss of friction. If this main lot of grains are available, so there is a loss of friction between the soil and the boulder. The grain will start rotating on its own. The boulder will remain there. Therefore, boulder tends to rotate. Sometimes, because of this lot of particles available, the boulder itself will start rotating with the cutter. And when this happens, we have to adopt some other methods to arrest the boulder. The loose boulder needs to be arrested in its position by cement grouting on the surface. Some tunnel boring machines have arrangement to grout from the face, but in this method, the injected cement grout, it may be very essential to protect the cutter. So grouting phase is taking place from the tunnel boring machine itself, And when the grouting is being done, the cement grouting is being done, we have to take care that the cutter head does not get affected by the by the grouting material, or else the cutter will stop moving. The cutting chamber will be emptied and all the excavated muck will be filled with slurry, bentonite, and cement. So, cutting chamber, wherever it is there, it has to be filled with this bentonite and this one, so that it does not get stuck to the cutting head. The machine can restart excavation mining after 24 to 48 hours for completing the groundwork, as injected grout needs to set. So whenever we are grouting the machine, grouting the rock in front of the machine, we have to put in this bentonite and the other thing, grouting machine materials, and we have to wait for 24 to 48 hours for it to set, so that the rock does not rotate and the cutting process can be taken. Several such situations were met while tunneling in the first phase of Bangalore Metro project, where repeated grouting was carried out to negotiate such areas of boulders. It is also noticed that the boulder in front of the cutter head causes considerable damage to the cutters and other tools mounted on the cutter head. Process of replacing damaged tool is called as cutter head intervention. In this process, the technician enters the cutter head portion under compressed air. He goes out, and then under a lot of pressure, compressed air, he goes there and he replaces the broken parts or any other alignments to be done, he does it. When the tunnel alignment is below water table, working under pressure becomes essential to prevent water. So we have to create enough pressure in front of the cutting head so that the water from the top, the sewage line or anything, does not seep into the tunnel. If there is an air loss happening due to disturbance of boulder, pressure cannot be maintained. When the boulder starts moving and there is a disturbance because of the movement, so the pressure cannot be maintained. In this condition, filling of weak mixture into the chamber has to be taken up immediately, and intervention done after completing cement grouting in this year. So a weak grouting material is injected inside this, and to make sure that the boulder does not move. Consumption of grout depends on the porosity of the ground in the area. As shape of the boulder cannot be assessed correctly, and the grouting has to be carried out at utmost with a trial and error method. So we do not know what is the size, what is the shape. So trial and error method, with this person sitting inside the chamber, he sees that and the grouting is carried out. When the area is surrounded by structures, building, grouting from the surface will not be possible unless buildings are evacuated. So we cannot do the grouting from the surface. So we'll have to, when we are doing this, and if the buildings are old, so it has to be evacuated and this process has to be carried out. Tunneling becomes very difficult when there are multiple boulders in front of the cutter head. If it is a solid rock, it is very easy to do the drilling part. If there are multiple rocks, it becomes very difficult for the cutter head to do that. So quantum of disturbance at the surface due to the moment of boulders will be much more in case in case of multiple boulders. So if multiple boulders are there, and if there is a single boulder can be cut because it is stabilized, it is there, cutting surface can be used very easily. But if it is multiple number of boulders there, it starts moving along and it becomes very difficult. So here near Vidhan Sauda, we had, if not drilled up and filled up depth, the boulder is into. So from outside, it was opened, and then it was the cement strata was put inside, and it was made to stand there, and the cutting went on. You can see the boulder here, you can see the soil here, and the soft soil is here, and again the boulder is there. So in between these two, lots of work. When we are working, small particles will start coming up, and it starts rotating, and the drilling operation becomes very difficult. So this is what had happened near Vidhan Sauda. Nearly 3 to 4 months was spent to open it up, remove it, and redo the job. Damage for cutting tools is also more. Arresting the boulders from further movement is also more difficult than in case of a single boulder. Boulder will not be of a regular shape, and injecting grout material is in such a way that sufficient ground quantity reaches the gap between the boulders, and is a difficult task. Since we cannot judge the shape and size of the boulder, the grouting materials is very difficult. By experience only, this man goes there and injects the the grouting material, and goes ahead. Further, there is no method to assess correct position and the size of the boulders. Grouting has to be done only based on observation of tunnel face from the cutting chamber, wherein boulders and other types of soil surrounding the boulder can be seen. So by experience, this man who goes and sees what is the size, what is the soil, and then the grouting is done based on his experience, and it is done in front of the cutting edge. Observe the impressions of cutting disc on the tunnel in the hard rock. In front of Vidhan Soda, we had a hard rock, and you can see the cutting making a mark here. So it is, if this is a hard rock, cutting is easy. If it is a mixed rock, mixed surface, it becomes difficult. So cutting in this where it is fixed, and if whenever you are drilling some material, if it is fixed, you are putting it into a vise and then drilling. If there is no vise and you start drilling, the whole object will also start rotating, and you may get damaged also. So that is the principle in which this hard rock is also being done. So boulders faced during tunnel are granite rock, and are very hard as a sheet rock. Comprehensive strength of the boulder rock encountered as high of 300 MPa. Cutting a granite boulder with the strength of 300 MPa is more difficult than cutting full face rock. Rotation movement of the boulder causes a lot of vibration in the surrounding soil mass, resulting ground settlement and damage to the structures above. So the rotation, if you do a very fast rotation, or if there is a very hard surface in front of the cutter, due to which the vibration is done, the surrounding buildings also will get affected, and there'll be a settlement or damage to the structure. In Chickpeta, we had done lots of such things, and if there is, we had put sensors into all the old buildings, and if the rotation is causing vibration, it was sensed, and then those buildings were evacuated, restructured, rebuilt, and then further cutting was done. So that was a very big challenge during the Chickpet area tunneling. More A movement of the boulder may cause pressure loss on the face of the tunnel, especially in case of EPB type of machine. Slurry may leak into the surface in case of slurry machine. Once the boulder becomes loose, it is not safe to continue excavation. So that's why we have to slurry has to be pumped in. We have to make sure that the boulder is fixed in place. We have to put all the slurry and the other materials, so that it gets settled, get it gets it will be arrested by the bentonite and other things. 24 to 48 hours is lost just to make sure that it does not move. Cutting granite boulder with a strength of 300 MPa is much more difficult than cutting. Yeah, soil investigation do not show the presence of boulders very often. You can see the geological profile between Majestic and Central, this one. So we have got silty sand is there. This is silty sand. Then you have got highly viritate rock. We have got moderate viriated rock, and this is the hard rock, the pink color. So you can see at every 25 to 50 feet drilling has been carried out, and you will see the difference. What are the things we encounter? So all this, here you can see rock standing from the very beginning, from here itself. The solid rock is here. Solid rock, you can find here, and suddenly here it is in a very deep depth it is available. Because of that drilling operation, we do not know what is there ahead of us. So your table shows the number of interventions. See how many times we had to intervene in the operations. You see the length of the tunnel. We were having two tunnels. One TBM one, which calls Helen, and another was Margareta. So one was coming in the opposite direction. So this was 715 meters. Another was 718 meters. Number of rings were 477, and in the other place 479. Date of starting was 14th May 12, and the date of starting here was 18 June 12. Date of breakthrough. So when the final breakthrough came, it was, see here, 14th May 12, December 26th December. Here it was January and February 13. It took nearly 13 months to cover the same distance, because of so many. Time taken in days was 205 days, and 223 days. Interventions, time taken. So here so many days were lost because we have to change the cutters. We have to do we have to make sure that the boulders does not move. So we have to pump in all the chemicals so that it does not. So like this interventions, you can see this 203. It has to add here also. So many interventions were taken, so many days were lost. Number of interventions were here. This is the time taken to make it all right. But the number of intervention here is 100 times we had to, stop work, remove it, redo the whole system. Here, the other one was 103 times. So total disc change. Disc means the cutter change. We had to do 381 times in the TBM1, and 349 times. So take these are several instances where damaging of cutter tools were observed just in one rotation also, because we do not know the size of the cutter. We do not know how much soil is there. So if the cutting, if it is in the soil, you have to change the cutter. If it is only rock, you have to change the cutter. If it is rock and soil, we have to again realign the whole system. So like that, intervention was done so many times, and because of that, the project got delayed. All such challenges due to the presence of boulders do not have specific solution. Each situation needs to be studied in a detailed considering the location of TBM, structure above TBM, and presence of water. Any problem faced due to the boulders can be overcome only if the boulders can be located and plotted in the soil investigation. If we know by advance that there is a boulder like this situated at this place, during the soil investigation, we can do this work well in advance. Soil investigation is carried out after finalizing the metro alignment. If in the urban area, soil investigation itself is difficult task. Usually metro alignment follows the road alignment. So wherever the big road is going on, we follow the same alignment so that we can go along the road itself. Metro alignment deviates when the alignment is mainly because if the curvature of the road and if it is very steep, we have to change the alignment above the road. Curvature in is 125 meters in MG Road and Kabban Park, Indiranagar, and SV Road. The curvature, if you are traveling in that metro, you can see the whole train bending, and it is about nearly 125 to 150 meters radius is the curvature. So that is how the whole system works. And because of such curvatures, the speed of the metro train, which is designed at 80 kilometers per hour, it runs only at about 30 to 40 kilometers per hour. So because of lot of curves in this area. So you can see this. This is in Indiranagar to Bayapanalli. Such curvatures are there. So because of that, the speed is reduced, and because of curvature, there will be a lot of vibration, and lot of vibration will cause vibration and sound problem for the other things. So we have to take care of the sound also during these areas. Soil investigation is carried out at every 50 meters or and also sometimes at 25 meters. Even close intervals, it is not able to map the boulders accurately. Also, soil investigation bores will be terminated. Soil sample soil investigation. Not even a single boulder has been identified or recorded anywhere in the soil investigation of phase 1 of metro. So when we have done every 25 to 50 meters, we went on drilling the place and we did the soil investigation. We could not identify even one boulder, but the maximum number of boulders came in that area. It is possible, if it is possible to record the complete strata only when the bore is drilled to the depth of the proposed alignment, irrespective of the depth where the rock strata is met. So we have to go complete, if we are planning about 60 meters, we have to go 60 meters, and the soil investigation has to happen till there. Even if in such cases boulder of size lesser than 25 meters will be remaining unidentified. So even when you are doing this, if a small boulder is there, we will not be able to identify when the soil investigation is done. The boulder of 3 to 4 meters diameter is good enough to pose all the difficulties mentioned in the above. So even a small boulder, a group of boulders come in the line of excavation, it can create a lot of problems. So this is how I had the previous slide we had shown. And a cannon was found while station excavation after drilling 1 meter of rock, a strata below which the recorded will be recorded as rock and investigation. And so this cannon was found in City Market, and also near Vidhan Sauda we had found two such cannons. This cannot be recorded. You can see this is the varying diameter, and they could not identify that. But as soon as the tunneling started, they could feel it and they found this. And I think they had to open the ground and remove this. So there is an alternative method like ultrasound technique or other one to record the size and depth of the boulder accurately. Precautionary measures like advanced grouting can be done 2 to 3 months in advance before carrying out the tunnel work, so that the grout will attain required strength before the area is subjected to tunneling. So if this technique of ultrasound technique is used, we can start using grouting before 2 or 3 months in advance, so that the strength of the grout is also good and the tunnel can be taken without any problems. So even changing the tunnel alignment can be considered depending on the distance of the rock boulders for the nearby station. So if you have got advanced techniques are used, we can even change the alignment of the tunnel. You see two more cast iron cannons of 6 meters long and 1.2 meters diameter were found during excavation in KR Market in the north-south corridor of the Bangalore Metro Rail project. If such materials are met during tunneling, there is no alternate uh, than making a rescue shaft to remove such. So if such things are available when the tunneling, it comes along the tunneling line, we may have to open a shaft. We'll have to do a open shaft, and then a person has to go down and remove this material from that area and again fill it up and go ahead. So in near Majestic, our machine got stuck. Our machine got stuck because of the mixture of the boulders and all those things, and the machine could not move even an inch afterwards, and we had to open a shaft on the ground. Then a tunnel was made to go down again across the line, go there, dismantle the tunnel boring machine, remove it from there, and again another machine was installed, and that's how we lost nearly 6 to 8 months for the whole process, and additional cost of tunneling shaft, making a shaft, removing the machinery, correction of removing the machinery, repair and reinstall. It took nearly 6 to 8 months, and lakhs of rupees were spent for this correction. Initially, a weak mix is injected from the machine itself to surround the cutter area so that the cement ground does not come directly in contact of the machine. So we will inject a weak machine so that the slurry will not come directly in front of the cutting head. Once this grout is set, usually 8 to 10 hours cement grouting surrounding the boulder can be done from the surface. From here, so once he puts all the slurry, he takes all the precautions, and then he grouts the cement grouting on the boulder. It takes about 8 to 10 hours for it to settle down. These were the things what happened in BMRCL, and I'm thankful to BMRCL Authority for granting me to publish this paper. Reference of this one is BMRC Technical Report Internal. That is the number. Special thanks to Engineer Subramaniam Gudge, Chief Engineer of Underground Projects, who is now extensively involved in the underground projects in Metro. I'll be showing you whatever I talked about. I will show you how this machine works. You will enjoy. I think whatever I have talked will get related to the operations, what it is. And thank you for patience, very patient hearing. So once you see this, you will understand whatever I talked about. Thank you very much.
Tell you about this amazing opportunity. Right now, they're having one of the biggest sales of the year. So अगर आप घर बैठे
दोस्तों इस वीडियो में हम लेकर आए हैं रेलवे के लिए बनाई जाने वाली सुरंग के निर्माण की पूरी जानकारी। वीडियो बहुत इंटरेस्टिंग होने वाला है। वीडियो पूरा देखें ताकि कोई जरूरी जानकारी ना छूट जाए। वीडियो अच्छा लगे तो लाइक और कमेंट करके चैनल को सब्सक्राइब करें। दोस्तों पूरी दुनिया में रेलवेज और मेट्रो ट्रेन्स का जाल बिछता जा रहा है, लेकिन बढ़ती पॉपुलेशन और शहरीकरण के कारण जगह की कमी हो गई है। ऐसा भी हो रहा है कि बढ़ती जनसंख्या के कारण पहले से बनाए गए ट्रैक्स कम पड़ रहे हैं और नए ट्रैक्स की जरूरत आ गई है। जगह की कमी के कारण इन नए ट्रैक्स को जमीन के भीतर सुरंग से गुजारा जा रहा है। सुरंग बनाने के लिए सबसे बढ़िया काम करती है टीबीएम यानी टनल बोरिंग मशीन। कमाल की मशीन है ये टीबीएम। 100 मीटर लंबी इस मशीन को लगभग सभी सुरंगों के निर्माण में इस्तेमाल किया जा रहा है। टीबीएम बिल्कुल एक ड्रिल मशीन के समान जमीन को चीरती हुई सुरंग का निर्माण कर देती है। टीबीएम की वजह से रेलवे की सुरंग बनाने का काम पहले से बहुत तेज हो गया है, लेकिन इस काम के लिए बहुत ही आधुनिक तकनीक और सही प्लानिंग की आवश्यकता पड़ती है। 100 मीटर लंबे टीबीएम मशीन से सुरंग बनाने के लिए 300 मीटर लंबे और 150 मीटर चौड़ी जगह की आवश्यकता होती है, जहां पर टीबीएम की असेंबली की जाती है। बिजी सड़क के आसपास इस जगह को तैयार करने के लिए कई बार पेड़ों को काटना पड़ता है या फिर सड़क को ही पूरा का पूरा शिफ्ट करना पड़ जाता है। रेलवे ट्रैक का कुछ हिस्सा सुरंग से बाहर और कुछ हिस्सा सुरंग के भीतर से होकर गुजरता है। सुरंग के शुरुआती हिस्से को बनाने के लिए कट एंड कवर तरीके का इस्तेमाल किया जाता है, जिसमें रेलवे सुरंग के एक हिस्से को बनाते समय जमीन पर जगह को साफ करके मशीनों और दूसरे इक्विपमेंट्स को सेट किया जाता है। जैसे जैसे टीबीएम आगे बढ़ती है, वैसे वैसे इन मशीनों को भी आगे बढ़ा दिया जाता है। सड़क और पहले से ही बनी रेलवे ट्रैक्स के बीच में इस काम को निपटाना होता है। जमीन और रोड की दीवार को सपोर्ट देने के लिए सैकड़ों स्टील के बोल्ट्स को मशीनों की सहायता से जमीन और दीवारों में फिट किया जाता है, जिससे सुरंग बनाते समय जमीन धंसने जैसी समस्याओं से छुटकारा पाया जा सकता है। इतने भारी भरकम मशीनों के साथ एक्टिव रेलवे ट्रैक के बिल्कुल नजदीक काम करना काफी जोखिम भरा हो सकता है, जिसके लिए बहुत अधिक सावधानी के साथ पूरे काम को निपटाना होता है। थोड़ी सी सावधानी हटी और दुर्घटना की संभावना बढ़ी। यही वो जगह है जहां से ट्रेन का ट्रैक सुरंग से होकर गुजरेगा। टीबीएम मशीन के कार्य शुरू करने से पहले सुरंग के छोटे से हिस्से को खुदाई करके बनाया जाता है। सुरंग का शुरुआती हिस्सा तैयार हो गया है, जो लगभग 100 मीटर लंबा है, और साथ ही सुरंग के सामने वाला हिस्सा भी फ्री है। इसी जगह पर 100 मीटर लंबी टीबीएम मशीन की असेंबली का काम किया जाएगा। इतनी बड़ी टीबीएम मशीन को ट्रांसपोर्ट करके किसी एक जगह लाना बहुत ही असंभव कार्य है। इसलिए टीबीएम मशीन के विभिन्न हिस्सों को अलग अलग ट्रांसपोर्ट करके यहाँ पहुंचाया जाता है और फिर मशीन के हिस्सों को क्रेन्स की मदद से आपस में जोड़कर पूरी टीबीएम मशीन को तैयार किया जाता है। देखिए, टीबीएम मशीन के सामने लगने वाले बड़े से कटर को भी जोड़ दिया गया है। टीबीएम की असेंबली पूरी होने पर मशीन सुरंग बनाने का अपना काम शुरू कर देती है। टीबीएम मशीन जमीन को काटते हुए आगे चलती है। मिट्टी और पत्थर के हिस्से घूमते हुए टीबीएम के बीच के हिस्से में गिरती है, जहां पर कन्वेयर बेल्ट लगी हुई है, जो इन वेस्ट मटेरियल्स को खींचकर टीबीएम मशीन के पिछले हिस्से की तरफ लेकर जाती है। टीबीएम मशीन के अंदर लगे 48 हाइड्रोलिक्स जैक्स प्रेशर डालकर टीबीएम मशीन को आगे कर देते हैं। टीबीएम मशीन की सबसे अच्छी बात यह है कि सुरंग बनाने के साथ साथ ये मशीन सुरंग की दीवारों पर कंक्रीट के हिस्सों को भी फिट कर देती है। कंक्रीट के इन हिस्सों को फैक्ट्री में सीमेंट, स्टील और पत्थर के रोडों से तैयार किया जाता है। कंक्रीट की प्लेटों के निर्माण से लेकर इन्हें ट्रांसपोर्ट करने के काम में भी आधुनिक मशीनों का प्रयोग किया जाता है। कंक्रीट के इन हिस्सों को ट्रांसपोर्ट गाड़ी का इस्तेमाल करके सुरंग के अंदर भेज दिया जाता है। सुरंग बनाते समय बहुत अधिक मात्रा में मिट्टी, पत्थर के टुकड़े, रेत आदि निकलते हैं। इस वेस्ट को भी इस्तेमाल कर लिया जाता है, जिसके लिए एक प्रोसेसिंग यूनिट को सुरंग बनाने वाली साइट के पास ही इंस्टॉल कर लिया गया है। ये एक मॉड्यूलर सिस्टम है और इसे अलग-अलग साइट्स पर जरूरत के अनुसार असेंबल और इंस्टॉल किया जा सकता है। प्रोसेसिंग यूनिट सुरंग से निकलने वाले वेस्ट को क्रश करके छोटे-छोटे हिस्सों में बदल देती है। इन मटेरियल्स में छोटे-छोटे कंकड़ के हिस्सों को कंक्रीट बनाने में इस्तेमाल कर लिया जाता है और बाकी वेस्ट मटेरियल्स को साइट से दूर किसी जगह पर जमा कर लिया जाता है, जिसे बाद में लैंडफिल के रूप में इस्तेमाल किया जा सकता है। देखिए क्या बढ़िया सिस्टम है। वेस्ट प्लांट से कंकड़ों को कन्वेयर बेल्ट्स का इस्तेमाल करके दोबारा सुरंग बनाने वाली जगह पर भेज दिया जाता है। 3 किलोमीटर लंबे इस सुरंग के रास्ते में 2 आपातकाल एग्जिट्स दिए गए हैं। सुरंग में किसी भी तरह की दुर्घटना होने पर इन्हीं रास्तों से लोगों को बाहर निकाला जा सकता है। टीबीएम के अंदर ही मशीन्स को चलाने के लिए कंट्रोल रूम बने होते हैं, जिन्हें बहुत ही एक्सपीरियंस्ड इंजीनियर संभालते हैं। टीबीएम की स्पीड से लेकर सुरंग की खुदाई जैसी हर जानकारी कंट्रोल रूम में मौजूद होती है।
Yes, type 2 diabetes can be reversed.
टीबीएम के अंदर लगे हाइड्रोलिक्स और सेंसर से बने सिस्टम का प्रयोग करके सुरंग की दीवार को कंक्रीट से तैयार किया जाता है। टीबीएम एक एक करके कंक्रीट की मोटी शीट्स को सुरंग की दीवारों पर फिक्स कर देती है। ये पूरा कमाल टीबीएम में लगे हुए हाइड्रोलिक्स की वजह से काफी आसान हो जाता है, जिसकी वजह से टीबीएम के अंदर बहुत ही कम वर्कर्स की जरूरत होती है। कंक्रीट के इन हिस्सों को सुरंग की दीवार के साथ साथ आपस में भी लॉक कर लिया जाता है। कंक्रीट के पीसेस के बीच के गैप को टीबीएम मशीन सीमेंट का इस्तेमाल करके भर देती है, जिससे सुरंग के भीतर की दीवार पूरी तरह से स्मूथ और बढ़िया फिनिशिंग के साथ तैयार हो जाती है। टीबीएम सुरंग के आखिरी हिस्से में बिल्डिंग्स और घरों के नीचे से गुजरती है। ऐसे में सुरंग बनाने के पूरे काम में एक्स्ट्रा सावधानी बरतनी पड़ जाती है। 3 किलोमीटर की सुरंग को तैयार करके टीबीएम अपने काम के आखिरी हिस्से में पहुंचती है। इस जगह पर टीबीएम के विभिन्न हिस्सों को एक एक करके अलग किया जाता है और उन्हें सुरंग वाली जगह से पूरी तरह से हटा लिया जाता है। सुरंग के आखिरी 100 मीटर के हिस्से को टीबीएम से ना बनाकर कट एंड कवर मेथड से बनाया जाता है, जिसमें सुरंग को जमीन खोदकर तैयार किया जाता है। इस आखिरी हिस्से में रेलवे ट्रैक सुरंग से बाहर आ जाती है और ट्रेन की ये नई ट्रैक जमीन के ऊपर पहले से ही बनी ट्रैक के बराबर पहुंच जाती है और इस प्रकार सुरंग का काम पूरा कर लिया जाता है। सुरंग बनाते समय जमीन पर से हटाए गए पेड़ों और बाकी चीजों को भी फिर से पहले की तरह लगा दिया जाता है। तैयार किए गए ट्रैक्स पर ट्रेन का आना जाना शुरू हो जाता है। टीबीएम मशीन का प्रयोग करके सुरंग बनाने के इस पूरे प्रोसेस को देखकर आपको कैसा लगा, हमें कमेंट करके
You can hear me, sir?
Yes, sir. Sir, it was very informative session. Thank you very much, sir. Sir, end or you want to continue something?
Yeah. So you have seen whatever I explained for nearly 1 hour, this man has finished in 8 minutes. He has shown you all the process. So I wanted you to understand what is tunnel, what is aligning, how it is placed, how the tunneling TBM is assembled, it is removed, and the waste material, how it is taken out. I think whatever I talked has been explained in that 8 minutes thing, and I am sure you would have enjoyed listening about the tunneling and also started realigning yourself towards the tunneling engineering. Now, the time for the third and fourth year people to find out what to do after engineering. Can we become tunnel engineers? How to go and where to go? How to apply? If you start working towards that, this will be the most important infrastructure project which will be carried out throughout the world. And tunnel engineers, as I told you, are not available at present. In the next 5 years, if you can become a very good tunnel engineer, go to Alstom site and find out how you can relate to yourself. So, like this, the whole world will be wanting trained, certified engineers for tunneling. So, please reorient yourself if you are interested in such challenging situations and circumstances. Please start working towards it. अगर मेहनत करोगे तो you will become very good. A tunneling engineer is drawing more than, I think, more than about 50 lakhs, and very very less people are available. You may have to visit the other countries to get trained and then start working in this line. So I invite you to become a part of tunnel engineering and start looking out in a different concept of civil engineering. So this is the challenge and this is an option. So please utilize this system and uh, you start orienting your career from today. So I hope I have conveyed to you a lot of information. And if you still want some more thing, my address is there. You can write to us I'll put on the best of the engineers. And if you are still in the university, you would like to visit the place where these things are happening, you may have to write through your college so that we can take you to the place, because a lot of safety devices have to be used. You can see the whole system. I think BLD can take the initiative. They have been doing it from past 20 years. I am associated with them. So we can do a lot of work together. Internship
Definitely, sir.
program on railway engineering, tunneling can also be taken up. Thank you very much for giving me this opportunity. And I really relish to be a part of BLD organization. Thank you.
Thank you, sir. It was very informative and wonderful session. I request participant, if you have any doubt or if you want to ask, you can unmute yourself and ask the question, or else you can write it in a chat box so that I'll convey to the sir. So if you have any questions, please unmute yourself and then ask the question.
The session was very long, so they must be wanting to run. Let them send the question.
Sir, I have a question. I have a question, sir.
Go
Yeah.
ahead, sir. Go ahead.
Sir, I'm Dr. Praveen Shiroy from Maharashtra.
Yes, sir.
Okay. Now, I have a question that such type of the courses are available in India for tunneling only, for tunnel engineer or for tunneling in India.
Yes, some of my associates who are working in Maharashtra, Bombay Metro, are now
Okay.
contemplating to start these courses, which we will be announcing very fast. So people in Delhi Metro and also in, I think tunneling in Bombay has been a very big challenge. And whatever tunneling work, the experts are now joining hands. I may be also a part of it. So in the next, as soon as you people come out of the college, this course will be available for you.
Okay, sir. Okay, thank you, sir. I will convey this message to my students, sir.
Yes,
Okay.
Sir,
Yes, sir.
most of the participants are professor and the assistant professor working in engineering college and all, and we have few from the PG level.
Okay, okay. I thought I'm addressing the student. Sorry.
Okay.
No, sir, it's okay, sir. Okay. I will convey this message to my students, sir. Okay, thank you, sir.
Yes.
Thank you.
So there's one question in chat box. So machine which were brought from Japan, how long it took to procure?
See, procuring is a process. It takes nearly, first the global tenders, all those things. And most of the, I think, excepting one, we had procured second-hand machines from Japan. So everything was bought, and the vendors themselves will provide all this information. They will identify, because they are the people who are going to work there. So all this process takes nearly 1 or 2 years, and transportation of this machine from Chennai to Bangalore itself took 6 months, because it was such a huge thing. We have to only move during the night hours. So procuring, installation, and making it work, it takes nearly 6 to 8 months.
Thank you, sir. Any other questions? Any other question? Or just type it in chat box or unmute yourself to ask the question. If there's no question, then we'll wind up the session. Anyone have any doubt?
I think the email has been provided. Sometimes people don't want to talk, so you can send an email and get information. I will put you on to the experts from BMRCL.
There's one more question from Giridhar Kumar.
Yeah.
Will the second-hand machine affect efficiency?
No, these are working machines, and the same engineers who are working on it will come along with that. It's a package. So the efficiency will not be deteriorating, and they will be very effective, and there is no question of doubting the machines. That was only to save cost. We had to buy those things because it was a working machine. So mostly Indonesia and I think China, Japan will be using it. Once the project is over, it has got no value. That's why they start lending these things there. just like your second-hand Maruti car. It is not. It is working, but since you have bought a bit bigger ones, you are selling it off. That doesn't mean that it is not working.
There's one more question. What is maximum depth in a Bengaluru for tunnel?
We have gone up to 60 feet, and some places I think somewhere 80 feet. I think in the biggest metro station in Asia is Majestic Station. You have to visit to see how the beautifully networked it is, and further it is going to become something extraordinary there, where you can come, stay, have boating, lodging, everything will be provided. That is the station with a very huge layout. I think that I'm not very sure. 60 is the minimum, 80 is the maximum, because we are crossing the two lines, east and west to this one, north to east, north to south.
With this, we'll conclude the session. Thank you very much, sir, for accepting our invitation. On the behalf of BLD Management, Civil Department HOD, the coordinator, Dr. Asif Iqbal Momin, extend very heartily thank to you for accepting our invitation. As a token of respect, we would like to give you the certificate of appreciation, certificate of appreciation. Please accept it, sir.
Thank you.
Sir.
Thank you, sir. Thank you very much, all the participants. This is a beautiful certificate. I'm going to exhibit in my office. Thank you.
Okay. Thank you, sir. Thank you.
Thank you.
Okay, all the participants, the feedback link will be sent in the chat box. So kindly fill the feedback, and that will be considered as attendance. Okay.
56 participants. Okay, good.
Yes.